Artificial intelligence and machine learning have changed the landscape of environmental monitoring and management. This has provided scientists, policymakers, and conservationists with more opportunities to gain deeper knowledge, make more accurate predictions, and implement more effective strategies. Do you know what is happening in this industry now? And how is AI involved in this? Hello, I'm Ludmila from AMAZINUM. Let's figure it out. We are seeing increasing evidence that artificial intelligence can prove an invaluable instrument in tackling climate change. So, what we can expect? At first, environmental improvement. With the implementation of AI and ML into environment monitoring and management of air, water and soil quality are significantly enhanced. Through air quality sensors, water quality sensors and soil sensors, we can make a deep analysis and create predictions. Based on this, decisions are made about today's actions, which of course directly affect the future. With ML implementation, we can scrutinize data sourced from a variety of outlets, make analysis of patterns, pinpoint pollutant sources, and predict pollution levels. In this way, enables authorities to proactively implement measures to mitigate pollution and safeguard public health. ML algorithms identify sources of water pollution, predict harmful algae blooms, and detect changes in various water quality parameters. This is possible by analyzing raw data, remote sensing platforms, and historical records. This valuable knowledge helps to take prompt action to prevent pollution, provide safe drinking water to the public, and maintain the health of aquatic ecosystems. ML algorithms can create soil quality maps, predict soil erosion, and determine optimal conditions for growing crops. All of this is done by integrating information from soil sensors, satellite images, and weather data. This valuable information empowers farmers to improve agricultural practices, in that time to preserve soil resources and mitigate environmental impacts. ML helps the agricultural sector develop more environmentally friendly practices. This way, they can predict yields, withstand droughts, and optimize resource use. AI systems can also recognize and track pests and diseases in real time. This enables farmers to implement targeted control measures and reduce crop losses. Such strategies have a direct impact on food quality, especially on reducing the amount of pesticides and fertilizers used. Secondly, AI has a magnificent impact on wildlife. Confused? Let me make it clear. Honestly, protecting endangered species stands out as one of the most global challenges confronting our planet today. It is not a secret. Therefore, technology today is our best ally in solving this complex request. By applying ML algorithms to large datasets, researchers can track wildlife populations and analyze their behavior, migration patterns, and habitat. Artificial intelligence offers tools and methods for tracking and monitoring wildlife populations. This can help strengthen conservation initiatives and ultimately prevent species extinction. Algorithms can automatically detect and track animal movements and determine behavioral patterns. All of this based on remote sensing data, camera traps, and acoustic sensors. This helps to estimate population numbers, model habitats, and predict the impact of environmental changes on wildlife. In addition to animal tracking, artificial intelligence facilitates the process of species identification and classification. This is especially important in situations where species distinction is difficult or when new species are discovered. Thanks to AI image recognition, you can quickly and accurately identify species in photos and videos, as well as track their changes over time. Another way to implement AI in wildlife conservation is by predicting the impacts of environmental changes on animals' populations. Through the analysis of data related to climate, land use, and various factors, researchers leverage machine learning models to anticipate the impact of these changes on species and their habitats. This predictive capability aids in shaping informed conservation strategies and identifying regions most susceptible to threats such as habitat loss. This information is pivotal for formulating effective conservation strategies, managing wildlife, and preserving biodiversity. Next is climate change modeling. AI models can help in simulations the intricate relationships among climate, ecosystems, and human actions, offering a valuable understanding of the potential consequences of climate change on diverse regions and ecosystems. ML algorithms can analyze vast amounts of climate data to identify patterns, trends, and relationships that may be challenging for traditional models to capture. Particularly, regression models and neural networks can be trained to predict specific climate variables based on historical data or emulate complex climate models, providing faster and computationally efficient approximations. It is also important that these models are adaptive and can continuously learn from new data, improving predictions over time. This is useful in a changing climate where historical patterns may not fully represent future conditions. With AI implementation, organizations can anticipate acquiring more precise and valuable insights. This allows to enhance the efficiency and promptness of efforts aimed at countering environmental destruction, ultimately securing harmonious coexistence among animals, humans, and their habitats. Nowadays, AI insights play a crucial role in the battle against climate change, and it can be highly effective cooperation in conservation initiatives. Also, it impacted accelerating research and discovery. ML algorithms excel at processing vast datasets of ecological information, revealing considerable patterns and relationships that conventional methods might overlook. This capability aids researchers in formulating novel hypotheses and attaining a more profound understanding of intricate ecological interactions and processes. AI-powered systems contribute by automating tasks related to data collection and analysis, liberating researchers from routine responsibilities and allowing them to channel their time and energy toward creative thinking and effective problem solving. To sum up, the main tasks that AI can solve and that are solving now are data analysis and modeling, anomaly detection, pattern recognition, decision support system, predictive modeling for climate change, integration with sector networks, precision agriculture, citizen science and environmental monitoring, automation and optimization, wildlife conservation and monitoring, resource allocation and disaster response. And this is only start of new era in interaction of AI and ecology. What about organizations? Of course, they benefit from technology. The application of advanced technologies elevates the precision of environmental monitoring. Using sophisticated algorithms and data analysis techniques, researchers can excel in detecting nuanced patterns, correlations, and anomalies within environmental data. This heightened accuracy empowers more refined decision-making and allows for targeted interventions, enhancing the effectiveness of efforts to address environmental challenges. AI and ML plays a pivotal role in streamlining diverse tasks like environmental monitoring and management, resulting in heightened efficiency and speed. The automation of data collection, processing, and analysis significantly diminishes the time and effort needed to derive insights and outcomes. Through the reduction of time on repetitive processes, these technologies optimize resource allocation, liberating valuable human resources to concentrate on more intricate and strategic tasks. This not only accelerates decision-making processes, but also enhances the overall effectiveness of environmental management initiatives. The integration of AI and ML can yield substantial cost savings in environmental monitoring and management. The optimization of resource allocation, identification of cost-effective solutions, and enhancement of prediction accuracy contribute to the reduction of unnecessary expenses. This approach underscores the economic benefits of leveraging advanced technologies in environmental initiatives. By offering early warnings, these technologies enable prompt actions to prevent further damage and facilitate timely remediation measures. The capability to swiftly identify and address environmental issues enhances the overall resilience and sustainability of ecosystems, contributing to the preservation of biodiversity and the well-being of both natural habitats and human communities. The Great Barrier Reef Foundation creates a better future for coral reefs and their marine life through innovative projects and global advocacy efforts. For more than 20 years, it has connected science, business, government, philanthropy, and community for the benefit of coral reefs. With their partners, the foundation funds, co-creates and co-delivers solutions where they are needed most, breaking down barriers, transforming systems, and solving some of the most complex and challenging problems that threaten the survival of coral reefs across the planet. One of these initiatives was the competition from TensorFlow Help to Protect the Great Barrier Reef. It is about Australia's Great Barrier Reef stands as the world's largest coral reef system, teeming with an astonishing diversity of marine life, including a lot of species of fish, corals, sharks, and rays. However, it faces significant threats, partly due to the proliferation of a specific starfish species, the coral-eating crown-of-thorns starfish. In response to this challenge, scientists, tourism stakeholders, and reef management authorities have collaboratively implemented an extensive intervention program aimed at managing costs, outbreaks, and restoring ecological balance to sustainable levels. So, the main goal was to accurately identify starfish in real time by building an object detection model trained on underwater videos of coral reefs. The traditional methods for finding crown-of-thorns starfish, called manta top, involves a visual survey of reefs every 200 meters. It is effective but limited by scalability, data quality, reliability, and traceability issues. To provide a step change in cost control, the underwater cameras will collect thousands of Reef's images, and the AI technology could drastically improve the efficiency and scale at which Reef managers detect and control code outbreaks. Our team embarked on a high-value project in the environmental sector, focusing on the development of an advanced neural network for starfish recognition. Through extensive data research, we designed a sophisticated neural network architecture tailored to process video inputs from diver cameras. During the experimentation and evaluation phases, we continuously refined the neural network architecture and optimized the input data processing to achieve superior performance. To benchmark our model, we conducted a comparative analysis with the TensorFlow team's results. By harnessing the power of AI, we stand poised to unlock innovative solutions, safeguard biodiversity, and foster a harmonious coexistence between humanity and the natural world. Are you still awake? Write to us and we will be happy to discuss the implementation of the latest solutions for your ecological project. You can follow the link below to our website and book a convenient time for you to talk. That's all for today. You can check more insights on our website in the sections Insights. Watch our other videos and subscribe to our pages in social media to stay ahead of this innovation game.